Hi everyone. I decided to record today's tutorial instead of doing it live because I don't think it's going to take long, and I'll be obviously available to answer your questions if there are any. But on the topic of language models, we discussed it and we looked at the architecture. It works kind of like this. You take some text, you tokenize it, pass it into the model, and it's supposed to be able to guess the next token, whatever that is, auto-regressively, so one after the other. And so here's what we're going to do. We're going to be using Hugging Face. And first I'll show you how you can use Hugging Face to load a model onto your Colab, and then you use it to generate something, and then I'll show you how you can train your own model. And it's all very straightforward, and this code is made for you to be able to just use it without necessarily having to dig too deep in the code. So first, on the topic of inference or generation, make sure you're connected to a GPU based runtime. So if you come up here and you choose runtime type, you're gonna have a bunch of hardwares, and if you're using a Colab for free, so you might have T4 GPU. If you don't, this works still. This code still works on CPUs, but it's very slow. So the inference or generation is only 4 steps long, and it's very straightforward. First, you import some dependencies, which is you import. In this case, we're using GPT-2, the GPT-2 model, and it has the model and it has the tokenizer which we're loading. If you go on Hugging Face, you will find plenty of other types of models, and each of them would probably have their own type of tokenizer or their own type of model. For example, here we can see that Gemma 7B, or actually most of the models nowadays, you use an auto tokenizer which automatically detects what kind of tokenizers to be used and what kind of model you want to use. But here we're just going to stick to GPT-2. So we first import those, and then we have to set our model name. So here the model name is GPT-2 medium, and I'm going to make it parameterize it so that you can change it as a parameter. We're going to do type string. And yeah, basically what you see here, the name you see here is the same thing as you would find here. So GPT-2 is already built in, so you just say GPT-2-medium. But if you're choosing a model from Hugging Face, let's say Google Gemma 7B, you can just copy this and then write it here, and then it's going to load that model. Just be careful, if your model's too big, you're going to get an out-of-memory error if your GPU is not big enough to handle your model. So that's why we're sticking to GPT-2, because we know that's 100% going to work. So let's load the model. We'll load the model, it will load the tokenizer pretty fast, the download as well. And once it's done, we're going to be setting the prompts and some model parameters and how we're going to use them. Now, as I explained in the lectures, there are some common parameters for language models, and there's temperature, there's context, and there's context size. In our case, this is done. In our case, our context size is our max length. Our temperature is this, 1.2. We set it. It's a little bit higher than 1, which means like we're going to get a little bit of randomness. And our prompt, which is our context, what comes before. And so we run that. It's just setting these, and this is basically just tokenizes our prompt. Nothing. This is the whole thing, right? Very simple. And then finally we generate the text, and you'll see that what's happening is it's using model.generate. It's taking our tokenized prompt, taking how much we want it to return to us, as well as the temperature, and this is like, if you increase this, you're going to get distinct sequences, so it's going to try multiple times. And we let doSample be true in order for the temperature to affect it. So as you can see, once upon a time where there hadn't been a war, we had all these conflicts which happened around the world, blah 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 blah. It talks, and it can be very interesting. So there it is, simple generation code. You can find the complete code over here. It's very short, very sweet, and it's commented sufficiently enough for you to be able to understand it. Now, for training, it's a little bit more involved, but also it's super simple. So as before, we import the libraries, the model, and the tokenizer, and then we're going to have to prepare a data set. Again, the code is written, so you don't really need to worry about it, but I'm going to walk you through how it works very basically. We have to set up some training arguments and initialize some object we call the trainer, and then we use that to train the model. Then we can save it, load it, and use it. Also very straightforward. So the first thing you have to do, though, in order to train a model, you need to get the latest version of transformers. And accelerate, which basically lets you to do the training. So first we run this, and after running this, we're going to need to restart our runtime. So I'm just going to wait until it's finished running, and this capture code here basically stops this cell block from outputting long text, which is like, oh, this thing was installed, this thing was required, this requirement is already satisfied, and so on. So once this is done, restart your session. Don't worry, all your files and everything you've done will still be here. If you've already loaded GPT-2, it's still going to be in your cache. So there's nothing to worry about. And here you'll see that we're importing some extra dependencies like text dataset, data collator, trainer, and training arguments. Again, these will all be used, but you don't need to worry about necessarily what they do. Again, this is the same thing as before. We're loading a model and a tokenizer. Both are using the same, actually I forgot to change this here, both will be using the same model name. Let's fix that. Oops. Oh, we're gonna use model name there. Yes, perfect. Okay. So, I think little mistake here. What is it? What is going on? Maybe I think we can't use a dash here, so we're just going to use an underscore. Yes. Yeah. Okay. Yep. That's done. Then we're going to be giving it a data set. So the way it prepares the data set is super simple. It takes this text data set function, which we imported earlier, and we pass the tokenizer to it, and we pass it the file, and we just say how much, like what kind of blocks we want. So if you increase the block, it's also going to increase the VRAM you need to use in order to do it. But then if you increase this size, you're going to have to decrease your batch size. And you'll have to figure it out by playing around with it a bit, and you'll understand, how to reduce the size of your data set when you're training a model specifically. Data collator, again, tokenizes your data and puts it in a way that your model can read from it one after the other. So for this data set, I have a bunch of curated data sets from before, and I'm going to take 1984, the book, as a TXT file. You can find a lot of these TXT files online, or you can turn your PDFs into TXT. There's different ways you can do this. If you ever run into a problem, let me know. We copy path, set the path here, and then if we run this, you'll see that it will start to prepare the data set. Is prepared. Now there is the matter of setting your training arguments. So training arguments is basically just what you want your training settings to be, just training settings basically, and this eventually gets passed onto the trainer, which is another object which does the training. The parameters are learning rate, batch size, epoch, how often you want to save it, how often you want to log your progression of loss. So you want to decrease your loss as you go along and you train the model, and how many saves you want to have as you're saving, because if you have unlimited saves, well, you're gonna run out of storage because you're gonna be saving your model. So I want to delete the first one and then replace it and go on. So we're gonna say 4 here, which I think is enough. Learning rates, I suggest you start with something like 1 e minus 4, which is 10, 1 times 10 to the power of negative 4. So it's like that. This is the same thing as this, I believe. Yes. Then yeah, epochs is how many times you want to go over your data set. So if we have 1984, you want to read the book 3 times, then we do an epoch of 3. Batch size tells you how many of those 128 blocks that the block size here has you want to feed into the model at the same time. There are 2 tricks here. The first trick is the higher your batch size, usually the better the quality of your model. So that this really helps, training. If you do it like this, your loss is going to be kind of like constantly going down. If your batch size is 1, it might just like go up and down and you'll never reach a good point. And for your learning rates, you want to decrease it over time. Let's say you do 1 epoch or let's say, I don't know, 300 steps, and then you see the difference between your 2 losses. I'll show you that, actually. I think that'll be better. Oh, I have the same issue here. Let's put there. Let's put there. Okay. Let's put there. Actually, save steps is not... we're going to use save every. I just changed the name because I think this makes more sense. Okay, there we go. We set those. Now for training, you just click, this taking the model, the training arguments we just defined, the data collator that also we called in the prepared data set, and our data set itself. And then it trains it. And you'll see that there's a training loss and there's some steps. And as we increase the steps, so here you see that every 20 steps it's logged. You'll see that the loss is going down. It's 8 here, now it's 3, and it's going to continually go down. And you're going to reach a point where the difference between like every 20 steps basically stops to decrease. So you're going to be like, okay, this is just going up and down, it's not going anywhere. That's when you can reduce your learning rate, either by a factor of 10, which is like this, turn into 5, or half of that 10, which is like 2e minus 5. 5, right, 5. E minus 5, and yeah, you'll see like here, like the difference has decreased. We can just stop, reset the training arguments, and then continue training, and you'll see that it should pick up from where it left off. Yep. Now we'll see that the training loss is going to continually go down. One more loss. Okay, there we go. So now we've trained our model for a bit. It's learned some stuff. We can save it in the current Colab. It's by running this, it's already being saved, and I think when you stop the training, it's also saved. Sometimes, in this case, it isn't. But if you had gone 200 steps, it would have saved. Yes, that's the case. So let's save it locally, and you'll see that it will appear under GPT-2_fine-tuned. You can also save it to Hugging Face. If you save it to Hugging Face, you're going to get a prompt, and you're going to log into your Hugging Face account, and then you'll see it if you do have a Hugging Face account. If you don't, well, I suggest you make one. Give me an error. Oh, it's this one. So this one already saved locally. You should be able to see it here. It's under GPT-2_fine-tuned, model.save tensors, and so on. And here they want us to put our token. I'm not going to show you my token, but basically if you go in your settings, you're going to have your access tokens, and you just copy paste that here and you log in. And then the next time you want to use it, during generation after training, this is for the code for a local generation. So basically takes it from this model path right here. Right now there is no checkpoint 200 because we didn't train checkpoints, so we're just gonna put it there, and we're gonna use the GPT-2 medium tokenizer size, because the tokenizer type, because we didn't save the tokenizer, so we're just gonna use the original one. And for all intents and purposes, this should do the job. Because I don't think we're training the tokenizer, we're just training the model. If I may be, like, there's a 5% chance that I'm wrong. If I am, and if you know that I'm wrong, let me know. Yeah, and you'll see that it will read the model from this directory that we assigned it earlier in output there. And yep, goodbye, brother. Come. Okay, there it is. The future of AI is in your hands. Oh wait, that would be the prompt. Okay, let me make these parameterizable so that you can use it, just as it was in the generation part. Type string. You can see the prompt here. I'm gonna put one for the length, basically. This is a integer, and I'm gonna put another one here. It's a number. It's a float. Yes, we're gonna move this to the end. There you go. Yeah, this should work. Same as the inference code up there, except we're just reading it locally. The only difference is we're giving it the model path relative to the content folder, which is here. And the tokenizer type, as you'll see, we're using GPT-2 medium, which is the same thing that was used to train it. So, and yeah, if we decrease the temperature, we're gonna get something that's more accurate to the representation of the data set you trained it on. And if you increase it, it's going to be more random. So pretty much that. And if you want to load from Hugging Face, first you have to log in, which is, if you've already logged in when saving, then you don't need to run this. And then you're going to have a model repository, which is, if you've saved it, you would see it under probably GPT, under your name. So here in Hugging Face, in your profile, you would see that you have a bunch of models. So it will show up basically here, and you can just copy this and put it in here. Here, for example, and you can read from it, and same thing, you know. And I'm going to add these parameters for you as well, if you want to play around with it. There you go. That we don't need. Nice length. And yes, let's put one for temperature as well. And let's remove that. Yep, and this should do it. That's it. So if you want to train your own model and you don't want it to be GPT-2, all you probably have to do is to change these to auto tokenizer and auto causal. What's it called? Auto model for causal LM, causal language model, and then that's it. You can generate it. And for the sake of completeness, and for you to get the big picture of what everything really looks like in one go, you could just open these complete codes. You'll have the training code here, again very short, right? And you'll have your GPT-2 inference example code, which I showed you at the beginning. So that's it. If there are any questions, if there are any extra topics you want to know, like using reinforcement learning or using DPO, direct policy optimization, and you want to get in more advanced topics, just message me, and I can help you out, either online, in person, or otherwise. So thanks a lot.